Very good evening and welcome to all to joining this fourth day advanced programming class. And I would like to welcome our Honorable Vice Chancellor Sir, Professor Shoykot Mitra Sir, and Mr. Prithimoy Sharnal, the HOD of Technology Cell. So now I would like to request to say something and to inspire us with specious words, sir.
Okay, thank you, Supriyo. I think this is the second class
Fourth,
of advanced C program.
fourth
Fourth class.
class.
And already the students, those who have attended the previous three classes, they have learned something about the advanced C programming, and I believe that this learning is quite effective for them. And this learning process we want to make more engaging because after all, you have to learn everything by yourself. We can facilitate your learning process, but ultimately, if you want to learn it seriously, then until and unless you are not engaging yourself in self-learning, it is not possible. All these tips, all these instructions, and all the things which will be shared by Prithimoy, this should be used for developing your deep understanding of the subject. So that's why my advice to all of you is, whatever you are learning from here, from Prithimoy, you take a note of all these things, but at the same time, study this subject with a deep mindset, and so that you can understand all the intricate details of these things. And as this is an advanced subject, once you are completing this subject, this course, we should be recognized as very, very effective and efficient programmers. And that level of skill you need to develop. This is for each and everyone who have participated at this program. And it is expected that all of you should be a very, very proficient and efficient, this coder or programmer as far as advanced C programming is concerned after you complete this course. But only we are attending this course at this digital platform will not serve that purpose. So besides this, you try to learn as much as possible, consulting different books or different resources which are available at internet or in textbooks. Prithimoy already suggested these many resources, and then our objective is to make some of you as the trainer of the future. And in this way, we want to integrate all the community through networking by our, all these persons who will be completing these advanced C programmings. What previously also, as far as basic programming was concerned, some of our participants, they are continuing their journey of this programming language by taking part in giving training to others. And this is quite encouraging and inspiring for all of us, because you see, we have a very large population, and until and unless we are not empowering a major part of our population, young populations, with this computer knowledge, our journey or our mission of making the entire nation computer proficient, that will not be achieved. And therefore, your active participation is required. So take a pledge that you will be learning very, very seriously. And in future, some of you or many of you will be a part in this learning process, reversing the role to act as, these resource persons or trainer for the future. So this is our expectation from all of you. We are giving you all this training with the expectation to make it sustainable, self-sustainable. So for the benefit of this country and community. This is our objective, and we want to achieve this objective through your active participation. I believe that I could clarify myself. I could send the message which I was trying to convey properly to you. And with this expectation, I wish you all the best. I wish you very, very effective and engaging learning. Thank you very much.
Thank you, sir. Thank you for your valuable speech and your message also. And really, it's মানে আমাদের যে স্টুডেন্টরা এর আগে যে স্টুডেন্টরা করেছে তারাও কিন্তু ট্রেনার হিসেবে অনেকে জয়েন করেছে। তো আমরা চাইছি যে আমাদের এই বর্তমানের যে ক্লাসে যে স্টুডেন্ট তারাও কিন্তু সেই পর্যায়ে আসুক এবং সেই রোলটা প্লে করুক। এটাই আমাদের এক্সপেকটেশন। তো এরপর আমি প্রীতিময়দাকে বলবো, রিকোয়েস্ট করবো যে কাইন্ডলি আজকে প্রোগ্রামটা শুরু করতে, এবং যদি একটু হিন্দি, বাংলা এবং ইংলিশ দুটো মিলিয়ে হয়। প্রীতিময়দা।
Thank you, Supriyo. Honorable Vice Chancellor, sir. Am I audible clearly? Okay.
Yes.
Actually, I am today. I am in different location, not in my home. So I actually use my hotspot, mobile hotspot for networking purpose. So I know what type of enthusiasm, what type of interest you have. Actually, I see. So therefore, I carry my own laptop and along with my mobile also. And actually, now I staying in actually stay in different location and different room also, and only alone. Okay, and I actually organize this class, and I request Supriyo that if anything happens, I actually just bother about that. I want to continue the class because I get there a lot of enthusiasm, lot of interest from your end. So I want to continue.
One thing
So,
you kindly announce by after the completion of this program,
yeah.
we want to certify some as trainers so that they can act on our behalf with this program,
Okay,
School
yes.
Connect program, for
Yeah.
giving training. So this for the previous program also and this program also, we want to develop certain certified trainer from the university to take forward this activity from our side.
Thank you, sir. So this is a very good opportunity because whenever universities certify you, so I think it is the actually really boost your career also, because you will be a teacher, you can train, and whenever in case of programming, in all subjects, not only the programming, in all subjects, whenever you are the trainer, then you actually learn a lot of things. So this is the one way, and I think that this is the only one way that by which you can understand or you can learn a lot of things, because whenever you give the teaching or whenever you teach someone, you will get a lot of experience and lot of questions from different, because you know that the student actually in different wavelength, they actually whatever you think and whatever you understand, that point that actually level of understanding you only understand when you will teach. Okay, so this is the one of the great opportunity that you will get. So I think that this is the advanced level C programming. Already in my basic programming class, some trainer already Supri informed that some trainer actually trained some lot of students. So in advanced level, because you know in advanced C programming you will learn lot of things. I actually I have started the assembly language and C. Then I will actually emphasis on operating system, networking, and also the organizational part and database with C language. Okay, so this is an unique opportunity you will get. So I think you will your devotion, your dedication. I expect your devotion and dedication in this regard. Okay, so today I actually. I got number of queries, number of questions from your end that you want to know more about the assembly language. So what's the different type of instruction? Why actually I have already explained why actually we use the assembly language, and you know that the assembly language is the fundamental part of the programming language by which you can do anything. So and after that, after assembly language, you know the C actually invented. So whenever you know in previous class, I have shown you that you can incorporate the assembly language in your C program. Okay, today I just explain more about that. So I will share the screen now, and I explain. Before that, I actually explain. I actually share my assembly language code that actually I have developed last class. Just 1 minute. Yes. So you see that whenever you write the assembly language, this is the normal syntactical specification of writing the any type of assembly language, whatever assembly language you actually write, you know that whenever we write the assembly language, we mention the model, what type of model we use. And this model actually also use this model type also used in our C language program. But we actually least bother about that, because in C language, in my previous class, I have shown you that in environmental variable, you can you see that there is a memory model is there. But we actually, what's the issue? We've simply concentrated on file and open and write something and compile and build and then run. We never actually try to investigate the other parts of the C compiler interface. So in environment of the C programming text editor, you already see that there is a memory model which is also small. But in case of the assembly language, it is explicitly mentioned. You have to mention what type of model, because the assembly language actually shows the similarity with low-level programming. So therefore, you have to mention everything, and for that purpose, you can, for that reason, you can do anything with the help of assembly language. Okay. So whenever you write the assembly language, you know that it mainly consists of the three parts. First one is the model part, which type of memory model you actually use. There are different types of memory model. So what type of program we actually write, this program mainly consists of 10 to 12 instructions, or maximum 30 to 40 instructions. So in that case, you use the memory model small. Okay, dot model small. Small is a memory model. So according to your specification, operating system actually occupy, or operating system give the assembler that amount of memory. Okay, so if your program is large, and if your program actually occupy huge part of the memory, so then if you actually add the model small, you will be not able to run your program. So mind it, whenever you write the program, you have to mention what memory you require for running the program. That memory model you have to mention at the beginning of your assembly language program. Here I use the small, and what type of program we will do, all of the small and teeny. So you have used the memory model small. Okay, but if you are interested in assembly language program, then you can actually you can learn a lot of things from the assembly language books. Actually, you will get the information from internet also. Before that, you have to understand the architecture, because in case of assembly language, what's the issue? As it is closely related with the computer organizational part, so you have to understand which assembly language means what type of infrastructure you have to write you have to learn, or you write your program. For example, if your computer processor is 8085, okay, so the instruction is different. But if your computer is 8086 infrastructure, okay, so then the instruction, what type of instruction we actually use here, this is actually 8086 instruction. Okay, so you have to understand what is 8085 instruction, what is 8086 actually infrastructure. And I will explain later when I actually cover the organizational part and C. Okay, so just you remember that whenever you write the assembly language, you have to first mention the memory model, which is small, then the data segment. For example, in case of the C, you see the procedural language. So at the beginning, always you actually write what type of data you actually use. Okay, for example, for procedural language, I have already explained that procedural language, you have to declare the data or variable at the beginning of the block. Main is also a block, loop is also a block. This is the interesting question, that in loop, please remember, in loop, in case of C, in loop, I can declare the variable. That variable actually acts as a local variable in that loop. For example, in main, if you use the int I is integer type of variable, and then in for loop, if you again declare, suppose the another variable, so that variable, that integer type variable actually locally represented inside this block, not outside this block. That means within loop, whenever you declare some variable, that variable actually acts as a local variable in this block. Okay, So this is the concept of the procedural language. So that means it actually, because whenever you write your program or whenever you learn the high level programming means fifth level programming, lot of generation of languages there, third generation, fourth generation, fifth generation. Okay, for example, in case of the now you know the artificial intelligence, AI, data mining, data science, one of the budding subject, lot of budding subjects are there. So in that case, whenever you write some AI level program, you can use the variable, you can use the procedure in different way. But in case of the low level programming like C, like Pascal, like assembly language, okay, so you have to follow what the syntax of that program. Okay, what the syntax means, what the grammar of the program. Okay, so after declaration, the memory model, you declare the data. You have to understand, or you have to just you have to clear your idea should be clear that what type of data you use. You have to mention here in data segment. For example, here I print the hello world. So therefore, I declare that hello world variable, string variable, message variable in data segment. Okay, if you use some integer or if you use some number, you have to declare the data segment in data segment. Okay, then you use the code segment. Code segment means where the basic codes are there. For example, the assembly language, you see that the assembly language mainly consists of number of instruction. What type of instruction? For example, consider the first instruction mov ax at the rate data or mov ds at comma ax. What the meaning of this instruction? Actually you concentrate on the left part of the instruction, which is mov. Mov means move instruction. Move instruction means actually you move this item from source to destination. Okay, actually you never move. Please remember, because in assembly language you have to use move in all cases. Okay, if you want to, today I will cover the jump, that means the conditional statement in assembly language program. So where you also see that move instruction actually used. So move is a specific type of instruction, specific type of operation that actually move the data from source to destination. So that you can understand that whenever I move some information from this part to this part, that means at the previous part, that means a source part, there will be no information. This is not true. That means if A contain the variable 2, value 2, and B contain nothing, then if I move the content of A to B, that means in next part I see that the both actually 2 present in both the cases. That means in case of A and in case of B also. Okay, that means basically move what type of operation? Move similar to the copy. Okay, you understand, copy. So I simply copy that information to that information from source to destination. So the value remain in the source as well as in destination. Okay, so I simply, whenever what type of operation actually I want to do, I have to move that information to say specific register. You know what is register, because I have already explained what is register. This is a teeny memory area where we can store something. So that means whenever I move that information to the register, then I will be able, that means my assembler will be able to assembling the instructions. Therefore, whenever I actually move the data, because you know that the data, there are a lot of registers. I have already explained that there are a lot of registers which is known as the general purpose register. The general purpose register is the AX, BX, CX, DX. A lot of registers are there. So today I will use 2 type of register. Okay, so here I use only the AX register, AX, and I move the content from actually whenever you read the instruction from right to left. That means I move the data from data segment to the AX. From data segment, look that, from data segment to the AX, not AX to data segment, from data segment to the AX. Next, I move the data from AX to DS. Okay, so this is the way where we read the instruction of the assembly language program. Clear? Now, this is the normal way by which I have already explained that actually I got some question regarding the register, regarding this move instruction. Therefore, I actually explained. So I already told you that whenever you write the programming in assembly language, at the beginning, you face a lot of problems. You don't understand what is the logic behind that. But whenever you get all the logic, then you see that the assembly language is very simple. But if assembly language is simple, so why this type of lot of languages are there? Only for that, this instruction. Because whatever you want to do, you have to remember the instruction code. Because in assembly language, lot of codes are there. Today, we will see also that there only for the if and else statement, whenever you write some program with the conditional statement in assembly language, you have to remember lot of instructions. This is the difficulty. This is the constraint of the assembly language. But in case of the high level language or low level language like C, whenever you use if, else, else if, etc. and etc., you only remember the if, else, or switch or case syntax, not anything more. But in case of the assembly language, you have to understand what will be the return of the conditional statement. And if it returns 0, then where I have to go. If it's return negative number, then where I have to go. So everything you have to chalk out, and everything you have to mention, everything, because assembly is a powerful language, because you can even move the data from one specific location to another location. So this is the normal structure of the assembly language I have already explained. So now I just stop the screen, share the screen, and I open the C language interface. Look that. This is the C language interface where I incorporate the assembly language program. Okay, this is simple because we use the ASM directives, and this ASM, with the help of the ASM directives, we can put the assembly language code here inside the C language program. So whenever I use the ASM, compiler least bother to compiling that process. So assembler actually involved, and actually, so the object file, whenever the object file actually develop, so that object file, both the compiler as well as the assembler are actually involved. Okay. For example, here I take 3 variables A, B, and C, where I assign 2 to A and 3 to B, and then I look that I move the content of A to the AX register. Look that content of A to the AX register. Then I move content of B to the BX register, because whenever you want to involve assembly language to assembly this code, you have to move the information to the data register. Otherwise, you will be not able to assembling. Okay. So your assembler will be unable to execute the program. So therefore, what's the content of the A? I simply copy or move the content of the A to the AX register, then content of the B to the BX register. Okay, because AX and BX are the general purpose register, GPR, for addressing. Memory as registers are there, for buffering, memory buffer registers are there, for stack. I explained in my previous class, stack register, stack pointer as there. You can, you know that there are 2 types of operation, push and pop. So you can directly use the instruction push, directly use instruction pop. Okay, whenever you use the push, so assembler will understand that you want to push the item into the stack. So you have to explain everything. Okay, for example, here, in case of C, I simply add C equal to A plus B. But in case of the assembly language, you look that. So in case of C, I can type here C equal to A plus B. Okay, but here, what I have to do for assembly language, I move the content of A to the AX, content of B to the BX, then I add AX and BX. If I want to add A comma B, I will be unable to do that, because assembly language instruction, you have to execute the assembly language instruction on the register. Okay, so therefore I take the content from A and move the content to X, take the content B, move the content to BX, then I add AX and BX, and then I move the content of AX to C. Look that, add AX comma BX. That means content of BX actually add with AX, because whenever they execute the operation in case of assembly language, it execute from right to left. That means add BX, content of BX actually add with AX. Okay. Now content of AX now move to content to C. Okay. Now I print the content. Here you can ask the question. Here also I use the C variable. Why not register? Because I simply, you understand what I am telling? That in other sentence, in other instruction, I actually use AXBX, AXA, BXB. That means I have to use the single register. I have to use. Okay, for example, in case of the add operation, I use AX, BX. That means the both content of the both register. But in case of the move, I can move the content from one register to another register, or one variable to the another register. Here I move the content of one variable to the one register from B to BX. Look that what's the difference between move BXB and move CAX. Here I move the content of the B to the BX register, but here I move the content of the register to the variable. You understand? This is a difference. What's the difference? In case of here, in this sentence, I move the content of B to the BX, but here I move the content of AX to variable. Here, content of variable to the register, but here, content of register to the variable. So this is a difference. Why? Because I want to print the content of the C. So I use again the printf statement, and I see the output. What's the output? The output is 3 plus 2 equal to 5. Okay. So look that this is the syntax. ASM, I think you actually write down the program in my previous class and you run the program and you simply install, because assembly language, assembler installing is not a critical. So you can easily install the assembly language assembler in your program with the help of the DOS box, and you open and you how to configure everything. I have shown with giving the URL. Okay. If any problem occurs, then you can send me the mail. Okay. And I will, of course, intervene to this matter. Okay. So this is a normal way by which, with the help of the ASM directives, we can incorporate the assembly language code in my C program. But what's the limitation of the ASM? The limitation of the ASM is that if you want to do all with the help of the ASM directives, you will not be able to do that. Okay. So in case of the C, whenever you understand the assembly language as well as the ASM directives, then you can identify where you put the assembly language and where you simply execute the C programming. For example, if you want to actually add something, you can use this type of programming code. But you, for the sake of simplicity, I simply ask you, is it feasible to you? No. Why? Because in high level language or in low level language like C, wherever you simply add the C equal to A plus B, why we are using this ASM code, lot of registers, lot of operations? It is only for what? Because we actually, through this method, we understand what's the execution process of the assembly language. Okay. So in actually next class, we will concentrate on writing the program directly in assembler. Sometimes we can convey that information to the C language, because both the C language and the assembler actually performs their duty side by side or simultaneously. Okay, so I can send the information from C to assembler, or I can send the information assembler to C. So there are a lot of references are there by which, when I have to use, when I will use, I have to determine when I use the assembly code, when I use the C program. It depends on me what type of problem actually exists. And because in case of the assembly language, you know that the execution process actually fast, because in case of the compiler, what the ultimately exe file will be required. So in case of the compiler, your program first compile to the object code, then from assembler actually compile it, and then linker loader involved, and ultimately you will get the exe file. But in case of the assembler, directly assembler and linker actually involved, and you will get the exe file. So of course this is the fast than the compiling than the C language. Okay, so if you want to execute the code, then if you want to see that code actually, I want to execute the code where I want to involve the assembler, then you can directly call the ASM, but you have to understand what the limitation of the ASM. Okay, I will explain one by one. Now today, what actually, I actually have already explained at the beginning of my class, actually different location, and I use my mobile hotspot, and actually I have some meeting on 6:20, so I have to complete the class today 6:15, but next day I will continue. Okay, so don't worry. So what today I want to do, I just stop share the screen. I just 1 minute. I actually open my Paint. Today I will cover the conditional statement. Just 1 minute. Conditional statement. This is the fundamental part, because whenever you write, whenever you learn the basics of the C program, you know what's the fundamental part of the programming language. First one is of course the variable. Second one is of course the conditional statement, and third one of course the loop, and fourth one of course the functions. Okay, now the advanced feature is array, pointer, structure, etc., etc. But in case of the assembly language, we have to learn, or we have to understand the basics of that. So we emphasis on first data, then simply code, and now we consider the conditional statement. So what is the conditional statement? You know that you write the if. You know that this is a if and else. So this is the conditional statement, if and else. So this is the if block, and this is the else block. So actually, you know that this is the computer memory. This computer memory contains the information. Okay, this is the computer memory, and it contains the information. And you know that there is in previous class I have already explained, there is a program counter, PC. PC is there, PC program counter. So PC actually fetches the instruction from the memory and it execute. Okay, then it increment to go to the next location and again fetch, again execute. So this is the normal process of the executing of your instruction. This is known as the fetch cycle, and another one is the execution cycle. Okay, so PC actually gradually move one by one. Okay, this is the normal process. But if you use some conditional statement, because all the execution, all the statement, all the instruction execution is simple, or all the execution process is linear, you never expect. Okay, so sometimes you use the if else, that means if condition, you can put some condition. When it's satisfied, it goes here. If not, it goes execute this. Okay, so in that case, the normal execution of the PC is not possible. So what the problem is there? Suppose if you use the if statement here, and if it is a actually I put the color here. Look that I put the color here. This is the true part of if. You know what's the syntax of the if else. If means true, else means false, and if it is a false part, look that if it's a false part, just 1 minute, it is a fault. Sorry, if it is a false part and I put it green, so this is the false and this is the true. Sorry. Oh, yes. So the red part is the, suppose conventional rule, actually I totally break the convention. So if part is the red, then the true part is red and false part is green. So if you consider that, so in that case, if you think that PC actually face this instruction, if it is true, then it execute this. But if it is false, then it jumps and execute. So this instruction. So in that case, this true part, execution of this true set statement is not possible or is not occurred. Okay. So this is the normal part of the any programming language, because also all the time your execution process will be sequential mode. You will be in sequential mode. You never expect. It may be conditional. That means if some actually some information is true, then it execute the true part. If some information otherwise, it execute the false part. Okay. So in that case, the sequential execution is not possible. So program counter actually jump from this position to this position and execute this. It simply ignore this red part position. Okay. So how it's possible in case of the assembly language? Because in case of the C language, you will be able to do that with the help of the if else statement or nested if else statement. But in case of assembly language, how it's possible? I show you the code, never execute, because whenever I write that code for running, it takes some time. So in next class, I will show you. But now I just show the information. What is the way? What is the way by which you can use the conditional statement in assembly language? Okay, this is very simple, because in assembly language, you use the CMP. CMP means compare. You use the CMP, compare, CMP instruction. This CMP instruction actually gives two types of output. Okay, either true or false. So you simply compare CMP, compare. Okay, CMP with AX, BX. That means I compare the content of the AX and content of the BX. If it returns something, what type of returns? So that means you have to understand what will be the return. For example, if we compare 2 and 3, I want to get which one is the maximum. So 2 and 3 number between the 2 and 3, then of course it will return what? It will return 2 less than 3 or 2 greater than 3. If I consider that 2 less than 3 is the true part, then I use the instruction, suppose jump instruction, jump JL. That means jump with lower less than value. Okay. So actually I have to know what will be the output, what will be the instruction. So I just show you one actually code here. Just 1 minute. I open the jump instruction code. Hello.
It is paint. It is open, sir.
Jump instruction visible, na?
No, the paint is open.
Okay. I just shared the look that jump instruction code. I just show you. Look that. So I compare first CMP. I compare the content of the two variable. It may be registered or it may be variable. Then what will be the output? I have to understand. But in case of the C, the compiler will understand. This basic difference you have to understand whenever you learn the assembly language, because assembler are not quite smart like the compiler. So that compiler can assembler can understand everything. Look that in case of the C, whenever you suppose you put A equal to 1, B equal to 2, and then you write if A greater than B, condition will be true or false. Yes. Then you write that A is maximum than B, else A is minimum than B. So compiler take the responsibility to compare the content of the A and B, and then it gives the output in which part it actually moves, either true part or false part. But in case of the assembly language, you have to mention where it moves. For example, I compare A and B, CMP A, comma B. That means it's compare the value A and B. Okay. Now, what will be the return type? If it is JE, that means jump equal. If both the A and B is equal, then it jump to one level and execute the instruction. Yes, both are equal. Okay. But if same, both are same, JE or JJ, if returns, what type of returns? If it returns 0, that means both the variable, if A and B are true, actually equal, then it returns 0. So I can use either JE or JJ. Okay. So I use JE, that means I force to assembler to check whether it is equal or not. Clear? But if I use JNE or JNZ, that means not equal. Any means not equal. So I force to check compiler that JNE, that means it is equal or not equal. I know that A and B are not equal. So this is the true part. You understand? So if I consider that both the number equal or not, so I first use the JE for the true part, and in case of else part, I use the JNE. This is the simple. You just understand. In case of C, what I do? If A equal to B, yes, so I use JE. No, I use JNE. Okay, so this is the if part, this is the else part. Similarly, here you consider greater than or equal to, GE, greater than or equal to, or not equal to. If I know that the number conditional statement is in nested format, so I can use GE or NL. G means greater than, equal to, or not less than. Okay, not less than or greater than, equal. Clear? Similarly, JL, if A and B are not equal and A is less than B, then I use the JL. Jump less than. J means jump. Where it jumps? It jumps to specific level where I execute the operation. Just you understand, I actually open the one Word document and I will show you that how we can proceed. Just okay, here I open the screen. Again, it creates a problem. So I stop. I open the, just 1 minute, I open the Word file. Just open the Word file. Yes, blank Word file. I write the simple instruction. It is very simple. Look that. I share the screen. Look that. First I move. That suppose content of A to X. Then I move content of BX. Content of B to BX. Then I compare CMP AX BX. So if AX is smaller than BX, so I use JL, or I can use the caps JL. To some I can give any level, suppose level small. Okay, where I mention level small, where I mention the procedure. This is not capital, this is the small, where I mention the procedure that I want to move the value of X to C. So this is the way. So how it execute? First it move the content of A to the X, then content of B to the BX, then compare AX and BX. Then what will be the return? I have to mention. So if it returns the less than value, that means AX and BX not equal, but AX is less than BX, then it jump to the level small, jump to this portion, and where it execute this instruction move where the content of AX to the C. This is the smallest, so I print the smallest number. Else I can jump to the, suppose I can jump here, JMP to label. Okay, and I also mention what's the label high. Label high. Okay, here I execute some instruction. Okay. So this is the way. This is the simple. So you understand the flow of conditional statement in case of assembly language may be of two types, either conditional or unconditional. For example, here when I use the CMP AX, comma BX, and then I jump to the level small, it is a conditional jumping, because here I use the jail jump less than this condition. So this is known as the conditional jumping. It jumps, program counter jump, program counter first execute this instruction, then execute this instruction, then compare it, and after that, if it is small, then it jumps to go this line. Okay, and execute contain the AX to C. Okay, but the sequential execution is, if it is false, then it moves to this and execute to this line, to this instructions. Okay, so there are two types of jumping. Either it may be conditional or it may be unconditional. Conditional means with some condition it actually jumps, and unconditional means it actually jump in normal execution. Normal execution, when program counter actually executes sequentially, this is known as the unconditional movement. Okay, but in case of the conditional jumping, certain with the help of or with some condition, it actually jumps from this portion to this portion. Okay, so don't worry, you just think that this is the syntax of the conditional statement in assembly language. I will because already 6:19, so sorry, because every day I will take 1 hour 45 to 50 minutes, but today I take maximum 50 minutes. Okay, so this is only for, because I am not in a position to continue the class, because tomorrow some actually events actually happen, so I have to look after all the activities. So don't worry, so in next class I will explain more, but you have to just 1 minute, just 1 minute. হ্যাঁ ম্যাডাম শেষ হয়ে এসছে, আমি আসছি। হ্যাঁ 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 আমি 2-5 মিনিট। হ্যাঁ, actually in next class I will explain more, because actually I have to stop now. So in next class again I will start from the move from the conditional, unconditional, but you remember these things, and whenever I explain, you see that this is very simple and this is very interesting. So only you have to remember that in case of the assembly language, you have to mention all. What type of operation you want to do, you have to mention, and what type of return occurs, you have to mention, because assembler is not intelligent like the compiler. Assembler don't understand anything if you actually implicitly represent. Explicitly you have to represent all. Okay, so next class I will definitely again start from this conditional, unconditional statement in assembly language. Okay, so I have to stop now. So Supriya.
Thank you, Priti Moeda. We are really great thankful to you for attending this class in this situation, Priti Moeda. Really.
Just 1 minute, just actually give the answer to Sija Mojumdar. Syntax of the move is without a semicolon. In case of assembly language, there is no requirement of semicolon. Semicolon only is for comment purpose. Okay. What is flag? Flag is actually, I will explain. What is one type of bit register? Either it may be 1 or 0. Suppose you actually execute the factorial of a certain number, so after that you will get some negative. Why? Because there is a limitation of the actually memory or the register. So when it is overflowed, then that flag actually arise their hands and you will get that negative value. So what type of operation actually of program counter or CPU actually performs, it depends on the flag register. Until and unless it is 0, then it executes the instruction. When the flag actually gives the value 1, then actually it stops the execution. Okay. Flag. What is a flag in a program? I have already explained. So fine, I will explain later. Okay, so today I have to stop. Supriya.
Thank you, Dada. মানে এই মুহূর্তে মানে এইভাবে যে তুমি ক্লাসটা করলে এই জন্য রিয়েলি মানে রিয়েলি থ্যাঙ্কফুল টু ইউ এন্ড
না ওরা সব হয়েছে, আমি ওই জন্য কন্টিনিউ করলাম।
ওকে ওকে
না তোমাদের নেক্সট ক্লাসটা আমি আরো বেশি করে দেবো, আজকে আমি পারছি না কারণ সবাই উপরে বসে আছে আমার জন্য, সেই জন্য আমাকে যেতে হচ্ছে। ঠিক আছে, আমি তাহলে লিভ করছি।
ওকে ওকে ওকে
ইয়েস ইয়েস, থ্যাংক ইউ। আমরা নেক্সট ক্লাসে সবাই মিট করছি আবার।
ওকে ওকে ওকে। So student, listen carefully. In this situation, Preetimadha attend this class, and our honorable vice chancellor already says that please practice carefully. And he got a we just give a lot of opportunity to you. So please carry on, continue this class, and we'll be meet in next Saturday, right, Prem? Next Saturday, 5:30 p.m.
Yes yes
Yes.
yes.
Okay. Now, thank you. Very good evening. Preetimadha, okay, তুমি লিভ করতে পারো।
Thank you.
And the parts, okay. Thank you.